In this video, we will tell you how to prepare the substrate and make the TFS 200 SL floor and TFS 500 EUC SL floor. Work and implementation of a polymer floor on your own should begin with the assessment of the substrate on which the floor is to be made. For the purposes of this video, we will divide the substrates into three categories. Category 1, very good substrate, smooth, without losses, requiring only manual grinding and priming. Category 2, good substrate with few cavities, requiring manual grinding, local filling and priming. Category 3, the substrate is damaged with numerous losses, cracks, uneven. Requires removal of detached elements, manual or mechanical sanding, cutting and filling cracks, filling cavities as well as putty priming. Regardless of the type of surface, each of them must be dry and free from contamination before we start work. For the purposes of this video, we will demonstrate the construction of a Category 3 floor. The next step is to select the flooring material, and calculate the amount of materials needed to complete the planned floor area. As a rule, the amount of materials should be calculated in accordance with the technical sheet of the system, and then add 10%. Once the substrate has been assessed, the system has been selected and the amount of material has been calculated, the flooring can be started. Note: before starting work, always pay attention to the conditions under which flooring work may be carried out. As we have already said, in this video we demonstrate the execution of a floor on a worn, uneven, cavity and cracked substrate. In such a case, work should begin with the removal of loose, detached elements of the substrate. Then score any cracks with a diamond disc. Then, the substrate should be ground with a concrete abrasive stone. After grinding, the whole thing should be thoroughly vacuumed, remembering to use a narrow suction nozzle to clean the cut slits. The next step is to prepare the compound for filling losses and cut cracks. To prepare the putty, use the TechniArt 400 RST, and fire-dried quartz sand with a grain size from 0.1 to 0.4 mm. Start the preparation of the joint compound by mixing component A with component B. Then add quartz sand and mix thoroughly. Sand should be added to the resin until a putty consistency is obtained. The prepared mass should be carefully filled in the cut slots, and then all cavities should be smoothed out evenly. Before commencing the priming operations, carefully protect all elements of the room that could be contaminated with resin by veneering. Remember that bonded resin is very difficult to remove. We start the preparation of the primer by weighing the appropriate amount of component A and component B of the TechniArt 400 RST material, remembering to prepare only the amount of material that we will be able to use in a short time from mixing. Epoxy and polyurethane resins after mixing should be immediately spread on the floor surface, because left in a bucket, they bind in a short time, and emit high temperature. To the previously mixed Techniplast 400 RSD ingredients, add quartz sand with granulation, from 0.1 to 0.4 mm, until the consistency of an easily pourable mass is obtained. Most often it is in a weight proportion of about 1:1 ratio. And it depends, as before, on the ambient temperature in such a way that the colder the less sand in the mixture. The prepared mass should be evenly spread with a stainless steel trowel. Priming of category 1 and 2 substrate can be done by applying the resin without the addition of quartz sand using a resin roller. However, it should be remembered that the best effect is obtained with a putty primer. The primed surface should be left to set for about 12 to 24 hours. Now you should start preparing the materials for the first layer of the floor. You should start with measuring the surface of the working area, and then calculating the required amount of material. Of course, using the technical sheet of the system and remembering the principle of adding 10%. In our case, they are 3 square meters. When measuring flooring materials, the volumetric method should not be used because it is not very accurate. The weight method is appropriate. Rule: resins intended for use should have a temperature of minimum 15 degrees Celsius. Component A should be carefully weighed, then component B should be weighed, in accordance with the proportion given on the package. Mix with a low-speed mixer, for about 2 minutes. In order to avoid excessive variation of the material, it is recommended to use a stirrer with a speed of about 300 revolutions per minute. Pour the material into a clean container and mix again, for about 1 minute. To make the floor, presented in this video, using the poured method, it will be necessary to use a squeegee, with a toothed insert, and a spiked roller, to vent the resin. After spilling the right amount of material on the planned working field, spread it evenly, using a toothed squeegee. The thickness of the floor will depend on the thickness of the teeth in the insert and, very importantly, on the angle of the squeegee. For this reason, it is very important to ensure that the tooth squeegee is steadily inclined throughout the resin decomposition process. After the material is evenly distributed over the entire planned surface, you should immediately start venting the floor with a spiked roller. You should remember to use spiked shoes, as you will need to walk on the freshly applied resin. The floor should be carefully rolled, using the cross method, until a uniform surface is obtained. Provided that it is cured at a temperature between 20 and 25 degrees Celsius, the floor is suitable for light loads after about 24 hours and obtains full resistance after 7 days.